Alrighty, but today we need to have a look at 6J, which is really putting the whole polynomial thing into use in the real world by doing the applications. We always look forward to this exercise at the end of the chapters. Now, this particular example, or the few examples that we're going to go through, these are very, very common types of examples that pop up in methods all the time. Yep, they love this particular box question. Yep. So it's worthwhile getting your head around this. This one pops up regularly. Yep, maths teachers, we love it. So it says here we've got a square sheet of tin and it measures 12 centimeters by 12 centimeters. Yep. So in reality you can have a square, a piece of paper, and you can cut out the edges and fold it into a box, a rectangular box. Now when we say we're folding it into a box, it's an open box that will look like this. There's no top on it. Yep. So in order to change a square sheet into a box so that you can fold it up, you need to cut out these corners. So when they're folded up, obviously they become the edges that go together. Now, they're saying here that 4 equal squares of edge x are cut out of the corners and the sides are turned up to form an open rectangular box. So again, if you think about it, the height of this box, open, is x. Yep. And that measurement x is the little square that you're going to cut out, because when they fold it up, that x measurement is the height of the box. Hopefully you can think that through and you're okay with that. So it's going on and it's asking us to do a few things. It says the value, find the values of x for which the volume is 100 centimeters cubed. So yeah, 100 is the volume. Yep. Notice, yeah, it's volume because it's centimeters cubed. Now, basically they're saying what could we cut in the corners here as the measurement of x so that this happens. Yep. Now, in order to do this, what we're going to do is we need to set up an equation for the volume of a box. Now, hopefully you remember that the volume of a three-dimensional shape is its length multiplied by its width multiplied by its height. Yep. Now, we need to actually work out what this length is, what the width is, and what the height is, and write it using algebra. Alright, so here is how you come up with the formula. If one of the sides is 12 centimeters in length before you cut out the ends, yep, 12 from here to here. If the height of the cut is x, it means you're going to be taking x off this side and you're going to be taking away x off this side as well. If you take away two lots of x, there's one lot of x there and one lot of x there, this measurement that's left is going to be 12 centimeters, take away the 2x. So that's one of the lengths. Likewise, no surprise, it's the same along here. If it was 12 centimeters in length in total, and you cut away x here and you cut away x here, it's obviously going to be the 12, take away those two lots of x. So we've got the length as 12 take away 2x, we've got the width as 12 take away 2x, and don't forget you've also got the height of the box, which is just x. So hopefully you understand how each of these has been derived. From here, as we said, you do need to know the formula for the volume of a shape. Yep. So remember, volume is equal to the length multiplied by the width multiplied by the height. So in this case, if you've got the length, which is 12 take away 12x, multiplied by the width, which is 12 take away 2x, then obviously that is, when you've got the same thing multiplied, it's just that value squared. So that times that is 12 take away 2x squared. From there, again, if you're going to multiply those by x times that, you can just put that at the front there. This is how this formula comes about. So the volume of the box is x multiplied by 12 take away 2x squared, which is length times width times the height. Now, notice on the end here, it says here the values of x have to be between 0 and 6. Now, the reason we have to write that is as follows. You cannot have a length, or you can't cut something that is a negative value. Yep. So it's even if you think about it for too long, your head will probably explode. But yeah, it's very hard to cut -2 length. Yep, it's not possible. Yep. So you can't have any values of the cut that are negative numbers. Likewise, here it's saying the value of the cut cannot be larger than 6. Now the reason for that is if you cut from the end here 6 centimeters, cut, you're here. If you cut 6 centimeters this way, cut, you've cut the whole thing off because it's 6 and the 6 is the 12 centimeters. So you've cut the whole thing. Yep, so you can't do a cut that is bigger than 6. Hopefully you understand what I'm saying there. Cool. So we've got, in this particular case, a cubic model. Again, it's cubic because obviously this here is squared. The x value is squared. Again, if you multiply x squared by x, it becomes x cubed. So it's going to be a cubic. It says here we're going to complete the solution using CAS calculator as follows. Yep. So yeah, you could calculate this algebraically, but for the sake of this exercise, they're saying we can use our calculator. So here is what is going on. On our CAS calculator, we need to be able to plot that volume. So the equation that we came up with, you have to be able to go into the graphing section and type in x bracket 12 take away 2x squared, and you should get this blue equation like so. Yep. Now, sometimes when you go to sketch it, you might have to change the zoom settings and so forth. If you want it to just display between 0 and 6, you'll have to adjust the window in using this setting here, set it between 0 and 6. Yep. So that'll work. Also, what they're suggesting is that we're going to plot a graph. So in the second section, so you're doing 2 graphs at once, you're going to plot in the volume as being equal to 100, because the question was asking for what values of x does the volume equal 100. So by plotting in an equation y equals 100 into y2, it'll sketch a straight line as such. Yep. From here, you can then use what's called the intersection. Yep. So when you've got both of these graphs sketched, and hopefully it looks something like this, you've put in y1 the cubic, and you've put in y2 as being equal to 100, which is this red line. You can go to analysis from the menu, you can go to Gsolve, and you can go to intersection. So what will happen is the calculator will do its thinking, hopefully pretty quickly, and it will show where they intersect, so where they cross over. Yep. So you can see here, it crosses over when x is equal to 1 and y is equal to 100. So the volume is 100 when x is equal to 1. So that's one of the solutions there for that, which is good. To find out the other spot, it's 100. Obviously, we can see here is the other spot where it intersects, where it's going to be 100. What you do, if you do the analysis Gsolve and the intersection, the little cursors there, if you press the arrow, the right arrow on your calculator to go across, it'll flip over and it'll go and show you this spot over here, and it will say where that location happens. Yep. So that's what it's saying here. Right arrow will give you the other spot where it is 100. So that'll be the solutions there, the 2 values where it'll give you a solution of a volume of 100. Perfect. The other part of this question was asking to find the maximum volume. So again, the maximum volume is obviously right up the top of this graph where the volume is going to be its highest. Yep. Now, in order to find out where this maximum volume is, again, you can use your calculator. So you'll get the hang of this pretty quickly. The analysis Gsolve section has powerful stuff. In this particular case, we don't want to find out where it's intersecting. We want to use Gsolve to find where the maximum occurs. So again, as soon as you go like this, it will find out where that maximum point is. Now, a word of warning, it's saying here, you must first remove the tick from Y2 and redraw the graph. So when you're sketching these graphs, just untick Y2 so it doesn't sketch the straight line across here. It just sketches the cubic. Otherwise, it could get a little bit confused about where you're trying to find the maximum. So get rid of the Y2 red line before you do it. Then go analysis gsolve max, and it'll spit out exactly whereabouts that maximum is. And it'll show you, okay, the maximum volume occurs when x equals 2. So that's when it happens. But the actual volume at that maximum spot, in this particular case, is 128. So sometimes you can't read it from there. These values 2 and 128, down the bottom here, the x coordinate is 2 and the y coordinate is 128. So sometimes you can read them down here a little bit better. Alrighty, cool. Oh, this one. We've done an example like this already, so this will just be double practice, I guess. It says it's found that 250 meter path of a stream can be modeled exactly by the cubic function that passes through the points. So we've got 0, 0, and the rest that we can see here. Perfect. Someone's taken the time to measure the path of the stream. Good on them. It's then saying, find the equation of the cubic function. So again, using CAS technology, we're going to do the following. So again, define the function f of x in this format, like we did in the other exercise. Enter the 4 equations shown with the simultaneous equations with the variables set as a, b, c, and d. So again, they're there. If you have errors and things, go watch the previous video where I explained how to do this. Using the variable and the ABC button is imperative to get this question happening correctly. Yeah. So here you will get the values of A, B, C, and D. So in this particular case, once you've got these values, you know you can write them as the actual equation and write it out. So the equation would be, obviously where A is, you'd have 19 over 375,000 x cubed plus these other values, etc., etc. What they're saying here is it would be recommended to store these values found as A, B, and C, and D by editing and copying and pasting them. Yeah, and you can actually go and you can say, okay, use this store symbol, which is in Maths 1. You can say store this value by clicking on it, copy and paste, store it as A, and press enter. Like this. So you can go, yeah, edit, paste the value, use the store button, store it as the letter that you want to store it as. Cool, so that's what they're doing here. They're storing each of those variables. It says here, once you've got that, it was asking to find what the maximum deviation of the graph from the x-axis is between 0 and 250. So it's saying here you can find the maximum value by typing in f of x and highlighting it, because that'll be the equation that you've got here with these values a, b, c, and d. Go to interactive, go to calculations, go to f minimum maximum, but obviously we want to make sure we select f max, and we can get that happening as below. They're suggesting as well, another way you could do it is, probably the way I would have done it as well, is to sketch it and enter the graph y equals f of x, or you could type it all out in there and it will sketch the graph. And then, like we did in the previous question, go to analysis, gsolve, and find where that maximum value is. Yeah. Perfect. Alrighty, thank you very much for listening in. I hope you have a great week, and I'll see you soon. Bye for now.